you suck at zero trust applications. We're going to look at how to build the policy enforcement points inside the application and how that application interacts with the data and how we're going to have a data-centric model for our database. So you suck at the applications and databases. Yes. Forgot to mention that part. First, let's go back to our problem, right? We're only going to focus on one application at a time because I don't think you can handle too many things at once. So we'll go with this application, and this application talks to this database. So your Active Directory authenticates to the application, but you also have these other outside enterprises who are going to have a business to customer connection and connect to the application as well. So you are going to have outsiders digging into your stuff. Now, here's the tricky part. Not every outsider is going to have the same level of access. So if there's 3 data tags, let's call them, or there's multiple data tags, and let's say this outsider can only view data with these tags, this outsider can only view data with these tags, but this outsider can only see stuff in between. Well, that's something we have to account for, and we're going to do that using the data centricity. So this is the overall problem scenario. Now let's go back to our application and building good old-fashioned trust algorithms, because this trust algorithm is the birthplace of the policy enforcement point. If you didn't watch the last video, I completely understand. Sometimes I want to fall asleep listening to my own self-talk. But remember these 5 things, because these are going to be key in building the policy enforcement point for our application. Now, this is something that I took from the 800-207 documentation from NIST, and it's essentially a broad overview of, or an operational view of the policy enforcement points for different apps or different workloads. And it makes it look like it has the policy enforcement point baked in. And this would be a containerized instance. As you can see, there's a sandbox or a container on OS on the side of the hardware. But this is just an overall format. We're not going to take action on that. We're not going to be launching one virtual device to host everything. Let's get into the higher level stuff from the documentation by, well, this time around, it's actually CISA and the DoD and NSA. These are just topics or points made for what a good application, a good zero trust application looks like. And you want to be in optimal. Over here we have the optimal. We have the worst on the bottom. We all understand if you can't get directly to optimal. And we don't expect that, right? You suck at zero trust for a reason. And that's because you can't go directly to optimal. So you're probably going to be sitting right here with your traditional everything. You know, you think you're cool because you put in engine X and you made it so you can use a username and a password. Well, I'm here to tell you that sucks. This is why you suck at zero trust. But anyhow, the most optimal way is that you can access this over public network. Cool. I mean, we can continually do that. You know, let's make this interesting. Let's say that this data was classified. Whatever, classified, secret. Let's make it more interesting by saying that this was a secret database that only secret nerds can get to, right? The requirement would still be you can access this over public networks. Now, that would make the scope of this a little bigger, but just keep that in mind in the future, right? You need to be able to access this, or the users need to be able to access this from wherever, whenever, and all those zero trust aspects are going to kick in. So those zero trust aspects will protect against sophisticated attacks. We'll have immutable workloads. Immutable workloads, meaning you can't change them during runtime. I'm not going to read all this to you. I'm just going to highly advise that you read all of this, because these two things say the same thing as far as accessibility options. So this is the big one that we want to focus on. It's going to continuously authorize application access, incorporating real-time risk analytics and factors such as behavior or usage patterns. So cool. Yeah, this is all the, the definition for zero trust applications and zero trust microservices, yada, yada. Now, this piece right here, this is all about the data. Here's your traditional stuff. Everybody knows this, right? Username, password access. We're going to have file-based permissions. You're going to have some encryption at rest. This is all basic stuff. What we're really going to want to focus on is this piece, the policy enforcement. Because data rights management is going to go back to, actually, it kind of leaks into the attribute-based access control and all the other policies we're going to have. These are going to be policies as well. This is beyond the scope, whatever. We're mainly going to be focused on these things right here. So data tagging. Now, in our database, if you go back to our problem scenario, our database, it's just going to be a relational database. So we're going to use columns for the tagging. We could be able to tag the resource itself, same with the application itself, but you know what? That is, again, a bit out of scope for this video. When we begin to go deeper into the architecture of actual resources, i.e., are we going to use Azure SQL? Are we going to launch a server and host Microsoft SQL Server? That kind of stuff. We'll go more into the data tagging of resources for that. But as far as data goes, these are just going to be your columns in your records of your relational database. Now, this piece right here is another interesting one. Basically, all that means is that you're essentially decrypting only the amount of data you need, and you're encrypting the rest. And based on the attributes, you're refining even more down to the just-in-time access of data. And that dynamic piece comes into play when you are going to do it multiple times on the fly. So now that we've fully drawn all over this junk, let's look at a data-centric protection. This is an operational view 2. So this was your OV1. This is your OV2. This goes just a little bit deeper on how the pieces are constructed, right? You have your dynamic data masking, your DLP policies. Everything's going to go back to your SIEM. And of course, your data tagging, your data rights management based on users. That goes back to the problem scenario, or piece of the problem scenario, when I mentioned, hey, these outsiders can only access this piece of the data. These outsiders are only allowed to access this piece of the data, so on and so forth. And again, this is all going to be secret data, super secret data. So let's just assume that all these outside enterprises are, let's call them governments who went in on your action, and you don't want to share everything with everybody, or sometimes you might not even be legally allowed to share everything with everybody. So we're going to use this OV2 to implement this idea here. Now these pieces, they're going to be enforced by attributes of the user. I'm not going to spell that. I will spell ABAC. Attribute-based access. Now, here is how our architecture is going to look. So essentially, you're going to have 3 tiers, right? You're going to have your application tier, or your presentation tier, excuse me. This is what everybody's going to see. This is how they're going to interact with the data, how they're going to find what they want, how they're going to build insight and knowledge using your data. Down here, we have the data itself. I'll just draw a table. That'll be a table. Yeah, table. Right here, we're going to have the data itself. And again, this is a relational database. We're going to have those attributes, the tags, rather, in the form of columns on a record. And let's just say this is a single database. There's no primary keys or secondary keys that relate different databases to each other. It's as simple as a document that has been produced and then attributes about that document, right? So it could be a date. It could be a classification. It could be who that document is relevant to, right? These could be the tags, and it's going to be this tag, who the document is relevant to, that we're going to use a big piece of the data rights management. So this is going to be connected to the users. Now in the middle, we have our middleware, or the policy enforcement point tier. And what we're going to do here is the user is going to authenticate first, and then you're going to get what they're authorized to do, i.e. can they read, can they write and modify data, can they add records. That will go a piece of that will go to the ABAC engine. And with that, you remember in our trust algorithm all the way up here, we're going to have these threat intelligence logs, as well as the access requests and their history. These are going to be fed into the ABAC engine, because we're going to build that continuous authentication detection and use it to make just-in-time decisions. And that will be paired with monitoring. I call this traffic monitoring, but this is just monitoring overall. So these two combinations right here, this is your true policy enforcement point that will cut access off when you are not cool. If you are no longer cool, you will not have access to this application. You'll be kicked off. So if you log in with a different device, if you were in Georgia and all of a sudden you're in Israel, you're going to get kicked off. If you are logging into if you're logging into the application using a web browser from your public library, we're going to track your IP and say, hey man, that's obviously, or woman, that's obviously not a cool place to access our stuff from. You're out. You're fired. Right? So this is going to be our full-on policy decision and enforcement point. This is going to be that dynamic decision-making body. Now over here, we're going to have your layers of protection of how the data is interacted with by the user. So we have the policy enforcement point. A piece of that is going to go into the data masking part. But now, on top of that, we have this extra layer of abstraction or protection to protect the data that's being fed to the application tier, or the presentation tier of the application. So the user is going to interact with the data using the front end. We're going to have the query passed on All those attributes will be fed into this to say, is it cool or not cool? The query will be made and sanitized so you can actually interact with the database. And by sanitized, I mean, again, is this user, what data does this user have access to? What's relevant to them? So we'll be able to cut out all the fluff with this data masking piece before we actually submit the query. We'll get the data. It'll come back through here, in which it will be processed. So that way we can re-encrypt anything we don't need, drop anything we don't need, all of that fun stuff before we actually present the data. So that, in a nutshell, is a high-level view of a zero trust application. Now, you may have noticed that we don't have the actual technology that we're going to use to implement that. That's going to be farther down the road. Right now, we're just getting into the architectural ideas. So if you want to join in, comment, go ahead and check out the GitHub. And I would love to have your thoughts on this, your feedback. Tell me if I'm wrong, so that way, again, I can crush your soul, because I need you to remember that you suck at zero trust, okay? The link to the GitHub is going to be in the description of this video. So until next time, take it easy and read a damn book.